This video is on two-column proofs. We're going to be doing two different proofs, proving triangles congruent. This first proof is a step proof where we have even less of the information given to us. And then in the next proof, all we have is how many statements there will be. So we want to make sure we get that many statements, and only that many. For this first proof, we want to prove that triangle ABC is congruent to triangle CDA. We are, in our first statement, we have BC is congruent to DA. That should be our first statement. We don't have it in here, so that should be what goes in there. Our second reason, or our second given, is segment AC bisects angle BCD. That is in the second statement, so that means that that would be our second given. So our first statement is our first given. Segment BC is congruent to segment DA. And the first reason is given. You just want to make sure that when you have step proofs, you read what's in the steps so you know that you can't say it twice. Because if they had put this statement first, I would have to put my BC is congruent to segment DA second. I have to be very careful about making sure I don't repeat anything. Then we have that segment AC bisects angle BCD. So I have this statement down here, and that second reason is given. I'm going to go and mark anything I can. So I have on statement 1, I have a congruency. Segment BC is congruent to segment DA. But then I have bisect, so that doesn't say congruent. What that means is that on statement 1, I have a segment congruent, so I can put an S beside it. I can't put anything on 2. That means I have to find 2 more pieces of information, which I can use one of my givens. This given is done because it's congruent already, but I can use this given to find something else. Maybe 2 pieces, but maybe only 1. There is a word in here, so I need to underline this word bisects, and then I circle the next part. Bisect means to cut in half. But bisect could be cutting a segment in half, or it could be cutting an angle in half. And in this case, it's cutting an angle in half. So it's very important that we're going to create 2 angles. 2 angles will be congruent. So we go to angle BCD. That's what we have to look at. Angle BCD, this angle right here. This segment here is going straight through the middle of this angle. What that means is that these 2 angles that it's creating will be congruent to each other. So we can say that this angle is congruent to that angle because this segment is going straight through the middle of this outlined angle, which is what it said it's bisecting. We have to make sure we know what to focus on. We're focusing on the angle, and angles, when you bisect an angle, it creates 2 smaller congruent angles. So let's write this statement. It says angle BCA. Angle BCA is congruent to angle. So we started with B, we need to start with D. D, C, then A. Again, it's just making sure you match them. So I went from B to C because that's where I have to go to, but then I want to make sure I only focus on this little angle. That's why I went to A. So if I want to focus on this little angle, D, C, A. And the reason for this is the definition. So the definition is bisect, but it's an angle bisect. So definition of angle bisect. Because bisect could go for either angles or segments. So you gotta be very careful in knowing if you're bisecting an angle or if this is a segment. So now I do have a congruency statement. This is an angle congruent, so I can put an A beside statement 3. But I still need 1 more because I only have 2. But I've used all of my givens. This given already gave me a congruent, and this given just gave me one. So I'm done with my givens. So I have to find something else. Well, reason 4 actually tells us if we're looking at reflexive property. reflexive property is when something is congruent to itself. If you notice, C and A, this segment, is actually on both triangles. It's what's splitting the two triangles. So the CA is congruent to itself. That's what reflexive property is talking about. So we can say that this segment is congruent to itself because it's on both triangles. And if we name it, if we put tick marks here, I want to name it on this triangle. If I start from C, where the arc is, to A, I want to go to this triangle. Name it correctly. I have to start from the arc, which is also at C, and I have to go to A. So we would say that segment CA is congruent to segment CA because of the reflexive property. Now that is a segment, and it is congruent. Now I have 3. So on here, I have SAS or SSA. Now, SSA spells a bad word backwards, so we can't use that. We know that that's not possible. But we have to be careful, because if we have a right angle anywhere in here, then this would work. It would just be called HL. But hopefully we never write this word. So if we look at this picture, we have no right angle. There's no right angle in our proof. There's no right angle in our picture. There's no right angle in our given. So we know that SSA is bad. Not good. Will not work. So it must be SAS. So we have to check that. I have 2 sides. So I'm going to cover up one of my tick marks, or one of these. And we'll end up having S, here's a side, and here's your angle. Now, we need the angle to be in the middle of our 2 sides. So if I go from one side, one tick mark, one set of tick marks, straight to the other tick marks. So if I go up and then down, that doesn't work because I'm not hitting the tick mark. I need to go down and then right. I do not touch the marked angle. So going from one side, down and then over, does not touch the marked angle. So this does not work for this triangle. This is not side angle side. This would be side side angle. This is bad. That means that these triangles are not congruent. Even after we did all of this, these triangles are not congruent. So we say not congruent, because this one would be side side angle. This one would be side angle side. So we can write this is side angle side in here, but this one is side side angle. Those don't match, so they're not congruent. And that's okay. So on this next proof, what we're doing is all we have are how many statements there are. So that means that we can prove it any way we want to, but we want to go in a logical order. We don't have to read off to see what we're given or what we have to make sure we write out, because if we see it one way and someone else sees it a different way, that's perfectly fine. We still always write our givens in our first statements. So statement 1 is that angle ADB and angle CDB are right angles. Angle ADB and angle CDB are right angles. So that is a given. And it's already marked. ADB has a right angle mark and CDB has a right angle mark. So that's marked for us. We also have another given. It says angle A is congruent to angle C. So we can put that in statement 2. Angle A is congruent to angle C. That is given. A has an arc on it and C has an arc on it. So that means that those are marked. Those are all of our givens. So let's look over on the side. I do not have on statement 1 a congruency, so I don't put anything. Statement 2, I do have congruency. I have an angle congruent, so I can put an A beside it. That means I need to keep going. So one of my givens gave us congruency, but the other one didn't. So what we want to look at, because we have a right angle, there's two things that you could do. There's two things. The first thing is you could try and prove hypotenuse leg. Hypotenuse leg is when you have the hypotenuse marked congruent and one of the legs. You would just, if that is going to happen, if you know that you're going to be able to prove the hypotenuse congruent, you want to go for HL. If there's no way you can prove the hypotenuse congruent, don't go for HL. Go for something else. So in this case, we cannot prove hypotenuse congruent. It doesn't touch. There's nothing in our given that states that. So we cannot use HL. That means we do not want to prove that it's a right triangle. We have to prove that these right angles are congruent. So again, there's two things you could do. If you want to prove HL, you would then say that these right angles give us a right triangle. But since we're not going to prove HL, we wanted to say that these right angles are now congruent. So that's going to be statement 3. That angle ADB is congruent to angle CDB because that is the right angle theorem. All right angles are congruent. The right angle theorem. Now we can say we have congruency, we have an angle and a congruent, so this is A. We now have two things that we have, two A's. We need to come up with a third thing, but we've used all of our givens. Since we've used all of our givens, we have to come up with something else from the picture. So if we go to the picture, these triangles are touching at that entire side of BD. That means that BD is on both of these triangles. So that would be congruent to itself. Segment BD is congruent to itself. We just have to name it correctly. This is the reflexive property. So in order to name this, I want to talk about this side right here. So if I start at the right angle, D, and go up to B, so that would be segment DB, is congruent to segment. I started with D, the right angle, so on this triangle, I'm going to start with the right angle, which is also at D. So it's also DB. And this is the reflexive property. I'm just going to put reflexive. I have a congruent. This is a segment congruent. So I put an S beside it. Now I have 3, and I should have my last statement will be my conclusion, so that I'm right at 5. So AAS is a possibility, and so is ASA. These are both possibilities because I have two angles and one side. So we look at our picture. I have an angle mark here, I have an angle mark here, and I have a side mark here. So if I want to go with my two angles, I have to go from marked angle to marked angle. I do not cross any tick marks. So it is not from A to A, I cannot cross anything. From A to A, I do not cross anything. So angle, angle, side is good. And that holds true for both angle, angle, and then the sides up here. So statement 5 will be whatever our proof says. So it's triangle ADB is congruent to triangle CDB by angle, angle, side. This, when you don't have step proofs, it's a little bit easier because you can kind of think of different ways to prove it instead of following along with what the paper tells you to do. So we've just proven these two triangles congruent.